Hello, my name is Dave and I manage the light microscopy side of the unit. Welcome to our confocal and our light sheet microscopes. So what's special about these two microscopes? Well, the problem with any optical system, be it your eyes, camera, a microscope, a telescope or a pair of binoculars, is that at any one point in time it focuses to a particular distance in front of it.
But unless what we're looking at is very thin, flat, and aligned perpendicular to the lens system, there is stuff, that's a good technical term, both in front and behind the focus point, which is seen, but is seen out of focus. So the in-focus things are superimposed on a blur of the outer focus things in front and behind them. This is why, when we look at samples on a conventional microscope, we try to make those samples as thin and flat as possible, often by embedding them in wax and then cutting very thin slices, about 5/1000 of a millimetre thick. We then mount these sections on flat glass slides. And then we stain the slides with chromatic dyes, which give the samples colour and contrast. This is all very useful, but this approach has several limitations. The higher the magnification you go, the narrower the range that's in sharp focus, so that even a very thin slice is thicker than the optics can hold in focus, and you end up having to focus up and down through the sample, trying to see the in-focus against the out-of-focus. The second problem is that these chromatic stains, and even the most complicated ones, are all rather crude. They will let you see tissue structure and distinguish cells from matrix, but little else. You can't, for example, see where a particular protein occurs in the sample, or where particular organelles are in cells, or track dynamic processes in living tissue. The third problem is that we are only ever looking at a very small region of our specimen. What if the feature of interest isn't in that region? We've missed it. And critically, biology doesn't occur in 2 dimensions, it occurs in 3 dimensions. So looking at it in only 2 dimensions means you're not getting a full view of how things relate to each other.
So, what we really want to be able to do is to look at our samples intact and in 3 dimensions, without all the outer focus stuff getting in the way, and use much more specific probes that only detect very specific targets in the sample, like particular proteins, organelles, cell types, and such like. And, being greedy now, being able to look at multiple different targets at the same time. And that's what the confocal here and the light sheet here allow us to do at different scales using different tricks of physics. The confocal works at higher magnifications from times 100 to times 1000 and allows us to see very small detail. Our light sheet works at much lower magnifications, but it can image much larger samples in one go, up to 10 by 10 by 5 millimeters.
Both allow us to create optical sections from within 3-dimensional structures by eliminating all of the outer focus information. Then, by refocusing the microscope, we can take a series of in-focus images at different levels in our sample, and then build these up into a 3-dimensional data set. Both microscopes work using fluorescence. We target the features of interest in our sample with very specific probes that fluoresce, that is glow, in a particular colour if they are exposed to light of a different particular colour. And then, by tagging different probes with different fluorescent dyes that glow in different colours, we can detect multiple different targets in our sample all at the same time. These really are fabulous microscopes, capable of generating stunning and valuable images. Click on the individual images in the virtual tour to learn more about them.